If you stood on the southern coast of France 5.5 million years ago, you would not see a sea. You would see a 3,000-meter abyss dropping into a lethal, shimmering salt desert, hotter than boiling water, emptier than imagined. In just 2 catastrophic years, nature unleashed a waterfall larger than every river on Earth combined. It unleashed the force of thousands of nuclear bombs every day to refill what we now call the Mediterranean. But what could drain a sea, and what chain of disasters could make it flood back so violently? The answer begins with the raw numbers behind this nearly impossible event. 3,700,000 cubic kilometers is the amount of water that poured into the empty Mediterranean basin. To picture that, imagine the entire volume of the Black Sea multiplied more than 100 times, or nearly 3/4 of all the water that evaporates from the world's oceans in a single year. This was not a gentle return. The Atlantic Ocean stood 1.5 miles above the sun-baked floor of the Mediterranean, separated only by a narrow barrier at Gibraltar. The difference in height, 1,500 meters, meant that every drop of water carried the full potential of a mountain river, but on a scale the planet has rarely seen. Volume. At the moment the barrier at Gibraltar finally gave way, the Mediterranean basin became the stage for one of the fastest and most violent floods in geological history. Water did not trickle in, it exploded through the breach. At its peak, the flow reached 100 million cubic meters per second. For comparison, the Amazon River, the largest on Earth, moves just 200,000 cubic meters per second. The Zanclean flood was 500 times greater, an unstoppable wall of water surging forward minute after minute, day after day. This was not a gentle stream. The Atlantic poured into the void with the force of gravity multiplied by a vertical drop of 1.5 kilometers. The energy released each day matched the detonation of thousands of nuclear bombs. The water's descent was so powerful that it converted potential energy into heat, sound, and raw mechanical force at a scale rarely seen on this planet. The ramp carved by the flood stretched for 200 kilometers, and the initial torrent tore through solid rock, deepening and widening the channel with every passing hour. Models show that 90% of the Mediterranean refilled in just 2 years. That means the sea level rose at a rate of about 10 meters every single day. In human terms, a city's skyline would vanish beneath the waves in less than a week. The process was relentless, driven by physics alone. Water seeks the lowest point, and the Atlantic had 1.5 miles of head to spend. The numbers become almost meaningless at this scale, but the consequences were real, unstoppable, immediate, and absolute. The Amazon's flow, mighty as it is, seems almost quaint by comparison. During the Zanclean flood, the Mediterranean basin was on the receiving end of a planetary scale release, a deluge that erased the salt deserts and canyons in a geological instant. The energy unleashed was so immense that it left scars in the rock, evidence that can still be traced today beneath the calm surface of the modern sea. In just 2 years, the Mediterranean rose from a scorched depression to a deep, living sea, setting the stage for everything that would follow. 6 million years ago, the Mediterranean was not a sea, but a low-lying basin trapped between continents on the move. Africa pressed northward, colliding with Europe in a slow-motion tectonic embrace. This relentless movement forced the land upward, raising the mountain chains that now form southern Spain and northern Morocco. The Betic and Riphean corridors, once gateways for Atlantic water, were squeezed shut as these mountains rose. Geological reconstructions show that by the late Mycenaean age, these corridors had become impassable, sealing off the Mediterranean from the open ocean. This closure was not the result of a single event, but of millions of years of crustal compression and uplift. The Gibraltar Arc, a sweeping curve of mountain ranges, became a natural dam. With the last connection to the Atlantic cut, the Mediterranean was isolated. What followed was a battle between water loss and water supply. The Mediterranean is a negative water balance basin. It loses more water to evaporation than it receives from rivers like the Nile and the Rhone. Without the steady inflow from the Atlantic, the balance tipped. Each year, the sea level dropped by about a meter, and over thousands of years, the basin shrank dramatically. This process left a fingerprint on the Earth's crust. As the water vanished, salt and minerals were left behind, settling in thick deposits across the basin floor. Seismic surveys today reveal these ancient layers, some up to 3 kilometers thick, buried beneath the modern seafloor. These salt giants, invisible from above, represent about 6% of all the salt in the world's oceans, now locked in stone. The Mediterranean's transformation was not just a matter of water loss. It was a geological reconfiguration, driven by the slow collision of continents and the closure of vital sea gates. In the absence of the Atlantic, the basin became a vast, evaporating desert, a place where the sun's heat outpaced every drop that flowed in, and the memory of the sea faded beneath layers of salt and time. Beneath the calm blue of the Mediterranean today lies a hidden archive, a layer of salt up to 3 kilometers thick, buried far below the sea floor. This is the physical memory of a vanished world. When the last Atlantic waters were cut off, evaporation raced ahead of every river that tried to fill the void. Each year, the sun stripped away another meter of water, leaving behind a crust of salt and minerals. Over thousands of years, the basin became a giant salt pan, so vast that it locked away roughly 6% of all the salt found in the world's oceans. Modern seismic imaging cuts through the mud and sediment and reveals this immense deposit, a geological monument to drought and heat, now trapped in stone. But the story of this lost sea is not just written in salt. As the water retreated and the floor of the Mediterranean was exposed, life adapted to the new landscape. The basin did not become a total wasteland. In the east, where rivers from the ancient Paratethys and the Nile still trickled in, shallow brackish lakes formed, a patchwork known as Lago Mare. Around 5.4 million years ago, these lakes became highways for animals. Hippos and dwarf elephants, species adapted to swamps and riverbanks, migrated across the exposed seabed. Fossil hunters have traced their paths in the bones left behind. Hippopotamus teeth in Sicily, tiny elephant skeletons in Crete and Malta, evidence that these creatures once walked from Africa to Europe on dry ground. Isolation shaped these animals in unexpected ways. On islands that formed from the highest ridges, elephants shrank over generations, evolving into dwarf species, some no bigger than a large dog. The hippos, too, adapted to their new homes, surviving in the shrinking wetlands of the Lago Mare. For a brief moment, the Mediterranean basin was a crossroads, a place where continents met and species mingled. But this world was fragile. The same salt that recorded centuries of drought would soon become a tomb, sealing away the remains of animals that could not escape what was coming. Every layer of salt, every fossilized bone, tells the story of a landscape in flux, of a sea that vanished, a desert that came and went, and a population of animals caught between continents. This archive remains locked beneath the waves, a silent witness to an age when the Mediterranean was not a sea, but a memory written in stone and salt. 5,330,000 years ago, the Mediterranean basin was a salt-crusted wasteland. Outside its rim, the Atlantic Ocean was rising. As the last glaciers melted, global sea level crept upward, pressing the Atlantic ever higher against the land bridge at Gibraltar. This narrow ridge, known as the Gibraltar Sill, had held back the ocean for hundreds of thousands of years. But the balance was growing unstable. The Atlantic surface now stood some 1,500 meters above the parched basin floor. The pressure difference was immense, a hydraulic head measured in kilometers rather than meters, with the weight of an entire ocean bearing down on a strip of rock only a few kilometers wide. The sill itself was not a seamless barrier. Geologists believe it was a patchwork of limestone and marl, fractured by tectonic strain and weakened by the relentless grinding of the continents. The exact moment of failure remains uncertain. It may have begun as a trickle, a small stream of Atlantic water overtopping the lowest point of the sill. Perhaps a storm surge or a minor earthquake shifted the balance just enough. What is clear is that once water began to flow, the process could not be reversed. Even a modest breach would have set off a chain reaction. Water pouring over the sill started to erode the soft rock beneath it. As the channel deepened, more water rushed through, carving a path ever faster. This is the runaway incision feedback. Water flows downhill, erodes the channel, which steepens the slope, which accelerates the flow, which cuts even deeper. The process is self-reinforcing. The initial stream became a torrent, the torrent a flood. Every cubic meter of water that crossed the threshold lowered the Atlantic surface only slightly, but it deepened the channel, allowing even more water to follow. Models of the event suggest that the breach did not happen all at once. For weeks or months, the sill may have hosted a river, its flow growing steadily as erosion widened and deepened the gap. The numbers are daunting. Global sea level rise at the end of the last glacial cycle may have added 10 meters or more to the Atlantic, pushing the system toward its breaking point. But the geological record offers only hints, no eyewitnesses, only the scars left behind. The Gibraltar Sill, once the gatekeeper of a vanished sea, became the weak link in a chain that could not hold. Gravity and water did the rest. Water pouring through the breach at Gibraltar did more than fill a basin. It carved a wound into the continent itself. In the first months, the Atlantic flow deepened and widened its path with relentless force. Instead of a single fixed waterfall, the incision moved backward, retrogressive erosion eating upstream toward the Atlantic as the water found every weakness in the rock. This was not a narrow cut. The resulting channel stretches nearly 200 kilometers from the Atlantic into the Mediterranean, and at its widest point, it spans about 8 kilometers, 5 times the width of Manhattan. The scale is almost beyond comprehension, a scar in stone created not over millions of years, but in a matter of months to a few years. Modern sonar and seismic surveys have mapped this hidden corridor. Beneath layers of younger sediment, scientists have traced a V-shaped scour channel, with steep sides and a bottom packed with a chaotic mixture of boulders, sand, and shattered rock. This debris is the physical record of the flood's violence. The channel's profile, broad, deep, and abruptly cut, matches what computer models predict for a runaway incision event driven by 1.5 kilometers of hydraulic head. The evidence is clear. Only a discharge measured in tens of millions, even 100 million cubic meters per second, could have gouged such a feature through solid limestone and marl. The process fed on itself. As the water rushed through the growing channel, it accelerated, and its erosive power increased with every meter of depth gained. The bedrock was scoured clean, leaving a trench that acted as a superhighway for the flood. In places, the channel walls show signs of collapse, with massive blocks tumbling in and then being swept away, leaving jumbled deposits now buried under silt. The modern Strait of Gibraltar rides above this ancient scar, but the original flood channel lies much deeper, hidden from view except in the echoes of sonar and the interpretations of geologists. This corridor was not simply a passage, it was the mechanism that allowed the Atlantic to unleash its full force into the Mediterranean. With the path complete, the stage was set for the next phase. A ramp, not a vertical drop, where water would accelerate to speeds that defy ordinary experience, transforming the Mediterranean from a desert back into a sea. The breach at Gibraltar unleashed more than a simple waterfall. The Atlantic did not plummet in a single vertical drop. Instead, the water raced down a colossal ramp, an ancient slope cut into the rock at an angle of 2 to 4 degrees, stretching for tens of kilometers. This geometry transformed the entire flow. Gravity, working over a distance of 1,500 meters, converted the Atlantic's potential energy into pure speed. As water barreled down the ramp, it accelerated relentlessly, reaching velocities that defy everyday experience. At the narrowest, steepest part of the channel, models estimate the flow surged as fast as 300 kilometers per hour, about 83 meters per second. That is nearly 3 times the speed of a racing car, but with the mass of an ocean behind it. At these speeds, water is no longer gentle or forgiving. It behaves more like a solid than a liquid, slamming into obstacles, stripping away rock, and pulverizing everything in its path. The force of this movement is measured in shear stress. At the ramp's peak, the pressure on the channel floor exceeded 10 million pascals, enough to erode even the hardest bedrock. The ramp's shallow angle, just a few degrees, was the key. It allowed the water to accelerate gradually, preventing turbulence from slowing the flow and directing nearly all the energy forward. The faster the water moved, the more efficiently it cut into the rock, deepening and widening the channel as the flood continued. This was not a single, fixed waterfall. The point of maximum erosion migrated upstream, chewing its way toward the Atlantic as the ramp extended backward. The result was a channel nearly 200 kilometers long and up to 8 kilometers wide, a scar that still lies hidden beneath layers of younger sediment. The jet of water that shot into the Mediterranean was so concentrated and so fast that it created a phenomenon called cavitation, tiny vapor bubbles forming and collapsing with explosive force, capable of vaporizing rock in an instant. The energy released by the ramp's geometry and the relentless acceleration of the flow set the stage for one of the most destructive natural events in Earth's history. The Mediterranean basin was about to be filled, not by a slow trickle, but by a planetary-scale jet, unstoppable, unthinkable, and nearly as powerful as nature allows. At the peak of the flood, the Mediterranean basin was subjected to forces that few places on Earth have ever experienced. As the Atlantic jet shot down the ramp at speeds of 300 kilometers per hour, the water's impact went far beyond simple erosion. At these velocities, water does not behave like the gentle current of a river. It becomes something closer to a cutting tool, dense and unstoppable. The pressure at the channel floor reached levels that could pulverize solid rock, and the most destructive process was invisible to the eye: cavitation. Cavitation begins when water accelerates so quickly that the pressure drops below the vapor point. Tiny bubbles form and collapse in microseconds, and each implosion releases a shockwave strong enough to pit and fracture even the hardest limestone. In laboratory settings, cavitation can eat through steel. Here, it was unleashed on a scale measured in kilometers. The ramp carved by the flood became a testing ground for cavitation, as billions of bubbles detonated against the channel walls every second, vaporizing rock and sending fragments tumbling downstream. The scars left behind, pitted, gouged, and stripped to the bedrock, are still detectable by seismic surveys, buried beneath layers of younger sediment. The violence of the flow was not confined to the channel itself. Where the jet burst into the western Mediterranean, the Alboran Sea, the energy was so great that it created a vast underwater gyre. This spinning current acted like a planetary sandblaster, stripping the seabed of sediment and scouring it clean down to the solid crust. Sediment cores taken from this region show abrupt transitions, layers of ancient desert salt abruptly capped by deep-sea ooze with almost nothing in between. The flood erased centuries of geological history in days. The sound of the event would have been overwhelming. Cavitation implosions, combined with the thunder of the jet, produced a roar that could be heard for hundreds of kilometers. Friction alone generated enough heat to alter the magnetic properties of rocks in the channel, leaving a paleomagnetic fingerprint still detectable in modern samples. The Mediterranean's transformation was not just a matter of water filling a void. It was a process of destruction and renewal, powered by physics at its most extreme, leaving behind a landscape forever changed by the briefest, most violent waterfall in Earth's history. 10 meters. That's how much the sea level in the Mediterranean climbed every single day at the height of the flood. In less than a week, the water would swallow a building the size of a city hall. For any animals stranded on the basin floor, there was no chance of escape. Hippos, accustomed to wallowing in brackish ponds, and dwarf elephants, some no taller than a child, became trapped as the water surged upward faster than any could run or swim. The numbers are unforgiving. At 10 meters a day, even the highest ground was only a temporary refuge. By the time the sun rose again, yesterday's island was already deep beneath the surface. As the flood advanced, the landscape transformed. Mountain ridges that once formed dry land bridges between Africa and Europe vanished beneath the waves. The peaks of Corsica, Sardinia, and Sicily became isolated islands, cut off from the mainland in a matter of days. Populations of animals that had crossed the basin during the dry years found themselves marooned. Some, like the dwarf elephants of Sicily and Malta, would evolve in isolation, their descendants shaped by the boundaries of water. Others, caught on lower ground, disappeared forever. The speed of the rising water left no room for adaptation. Every valley, every salt flat, every ancient canyon was erased beneath the advancing tide. What had been a vast, sun-baked desert became a patchwork of islands, then a single, unbroken sea. The flood did not just fill the basin, it redrew the map of the Mediterranean, transforming continents and sealing the fate of every creature caught in its path. In Sicily's Noto Canyon, the rocks hold a silent record of the flood's violence. Here, geologists have traced a sequence that begins with a layer of chicken wire gypsum, a tangled crystalline salt formed when the last water evaporated from a dying sea. This gypsum is not just a marker of drought, its tangled fibers and massive thickness reveal a world where evaporation outpaced every river, leaving behind a crust that once stretched for hundreds of kilometers. Directly above this desert relic, the story changes with shocking abruptness. The next layer is pelagic ooze, soft gray mud built from the remains of plankton that once drifted in deep open water. These microfossils, invisible to the naked eye, are the fingerprints of a thriving marine ecosystem carried in by the Atlantic as it surged across the basin. The contact between these layers is razor sharp. There is no gradual transition, no band of swamp mud, no trace of slow return. Instead, the gypsum ends and the marine ooze begins, with nothing in between. This missing time is the geologist's proof that the flood was not a slow process, but a geologic instant. In core after core, from Sicily to the central Mediterranean, the same pattern repeats. Desert salt, then deep-sea mud, separated by a boundary that could only have been created by sudden catastrophic inundation. The chaotic jumble of boulders, sand, and fossils within the Truby Formation, megabreccias thrown down by the first waves, adds to the evidence. The rocks themselves testify the Mediterranean's return was not a gentle rebirth, but a convulsion that erased the old world and began the new in a single unbroken leap. The return of the Atlantic did more than erase a desert. It wiped out nearly every trace of the life that had adapted to the vanished sea. The brackish lakes of the Lago Mare, once home to hippos and dwarf elephants, vanished beneath a surge of salt water. Freshwater species isolated for thousands of years faced extinction in a matter of days. The sudden arrival of the Atlantic brought not only water, but an entirely new cast of marine life. Sharks, whales, and plankton swept in with the flood, colonizing a basin that had been empty for generations. Nearly all the species found in the Mediterranean today, fish, mollusks, even the tiny creatures that build the base of the food web, can trace their origins to the Atlantic invasion that followed the flood. The impact of the refill was not limited to biology. The staggering mass of 3.7 million cubic kilometers of water pressed down on the Earth's crust, causing it to sag by hundreds of meters in places. This sudden load changed the shape of the land, warping the region on a scale visible from space. Some geologists have speculated that the weight of the new sea may have set off a chain of subtle shifts deep underground, possibly nudging faults and, over thousands of years, influencing the timing of volcanic eruptions in southern Italy. The evidence is clearest in the rock itself. The Mediterranean basin, once a lifeless salt flat, became a vibrant sea almost overnight. The world beneath the waves was reset, and the geography that would one day shape civilizations was born. Today, the Mediterranean shapes the lives of 500 million people, a sea born in just 2 years by forces beyond imagining. As climate change redraws coastlines and water scarcity redefines possibility, the lesson is clear: nature's tipping points come without warning, and their consequences last for ages. The world we inherit is never as permanent as it seems. What would you do if the flood came tomorrow? Share your thoughts below.